Thank you, Mr. Chairman. Ladies, ma'am, gentlemen, thank you for appearing before the committee. Thank you for the work that you do for our nation and indeed our world. This committee is certainly committed to the revitalization of NASA's manned space program. Keeping that in mind, we're also committed and indeed bound in our duty to protect and be careful stewards of the people's treasure. So considering the fact that new technologies are developed every day, technologies like carbon nanotubes, which have, the diameter of 10,000 times less than that of a human hair, they're stronger than steel, and have the stiffness properties of diamond. 3D printers, which are developing quite remarkable products every day with new technologies across the world. It leads one to wonder, considering although the unbelievably successful service that the existing International Space Station has rendered to America and the world, leads one to wonder whether or not the continued investment beyond 2024 in the ISS is reasonable. On the other hand, the same technologies that are being developed, which could ultimately lead to perhaps a next generation International Space Station, will also present us new opportunities to extend the life of the existing space station. So my question, first to Mr. Gerstenmaier, specifically regarding manned space flight and deep space exploration for an American space program led by NASA, do you envision beyond 2024 the existent ISS to be in any way useful for that manned space exploration, or does it have a role? Do you envision that role? And if so, please explain, and if not, please expound.
Yeah, I believe the station has a critical role in exploration as we have technical challenges that we have to conquer or overcome as we go beyond low Earth orbit. The requirements to keep technology highly reliable with low resources, to be essentially break the tie back to the planet Earth. Space station is resupplied all the time today by cargo vehicles to and from the Earth. But as we move human presence deeper into the solar system, we need to break that tie back with Earth. And the space station is a great test bed to test that technology, to understand the next generation of life support systems. We tested the systems for many years on the ground terrestrially before we took them to the space station. They did not work nearly as well in space as we had anticipated because of the loss of gravity. The carbon dioxide removal system is still a problematic system for us on board space station. We can operate it and keep it working well, but it's not easy. We need to use the unique properties of space station to actually test that next generation of life support systems. Understanding how the human performs in space is important. And understanding even how we break that tie and we keep sensors like oxygen measurement devices calibrated for years without returning to the ground for recalibration. So I think station plays a pretty critical role. I don't think we'll have all those technology challenges done. We're going to need some facility in space beyond 2024 to keep working those items as we break the tie of the planet and move human presence further into the solar system.
Dr. Dittmar, would you comment on that question, please?
I don't think there's any disagreement that we have to move off station. I think the only issue is when and how and what needs to happen between now and then. So it's already been talked about that there has to be a transition plan of some type. I don't know about you, but I really like a certain amount of certainty. As a business owner in particular, I like it when I can predict outcomes. I don't like it when I can't predict outcomes. This is one of those circumstances where you just can't really predict the outcomes. We do know that there are certain things that have to happen, right? We have to meet as many of the research objectives that are involved in going to deep space as we possibly can. And NASA, in fact, has a risk matrix that it's been burning down, okay, doing that kind of research. We know that we want to enable researchers like Dr. Ferl to be able to do as much research as they can, and we want to establish some mechanism for them to be able to continue to do that research after we're finished with ISS. We know that for all the reasons that Bill just talked about and that Eric just talked about, we want to be able to continue to have facilities available for people to do commercial development, as well as to be able to test systems that we need to go into deep space. So the only real question is, how do we get from here to there, right? I mean, that's the question. That's the one that's sort of facing everybody. The kinds of things that we know we want to allow for more time for have to do with commercial development, the kinds of things that we've already been discussing here, learning what kinds of systems work we may need to do as we go forward into deep space. So do I think that this is a value to the nation to continue doing this? I certainly do. The unique properties of microgravity are things that we're just still starting to, I mean, we're really just early in trying to figure those out. Think about when radiation was discovered and all the things that we've learned about what to do with that in the years since, right? We have no idea when we first started. That was a unique physical property, right? What we've learned to do with that in the decades and decades since is extraordinary. It actually is in most aspects of our lives. So I think that I hate to counsel patience, but I'm going to counsel patience. We need a little bit more time, I think, to allow these things to develop before we can get a real clear view of what that transition looks like.
That's a very helpful response. Thank you both, ma'am, gentlemen, for appearing today. Mr. Chairman, I yield back.